Hey, you guys. We're back now doing a whole different unit. We finished all the 3D figures, finding the volume, surface area, all those things. Now we're moving into what I like. This is a fun field of math for me, data analysis. We're going to be looking at numbers, crunching numbers. Growing up, I used to collect baseball cards. And I used to love baseball because it had a lot of things like average, like batting average and earned run average. And when I watch sports, I look at basketball games and I want to know what the players, scoring average is and things. So this is today's lesson that we're starting here with. We're learning about two measures of center. So a measure of center is looking at a bunch of numbers. So we're looking at some statistical data, data that deals with a bunch of numbers, counting things, more than one, usually a lot of numbers. And you take them and you try to find a measure of center wants just like a typical, what you would expect when you look at all of it together. So mean and median are two different measures of center. They are not the same, but they're similar because they both give you that typical data that you would expect. So the first one we're learning about is mean. And mean, sounds weird, means average. So you're just finding the average. What you see here is there's two steps for mean. So first, you want to go ahead and find the sum of all the data, of all the numbers. So you add up the values of every piece of data you have. In my example that we'll get to in a second, notice 0 is a data value. That is something that literally did or did not, I guess, occur. So I'll talk about it in the frame of, baseball, because that's something I enjoy. Sorry for you non-sports people. So first you add up all the numbers values, find out the sum, the grand total. Then step 2, you take that total and you divide it by how many numbers you added. Okay, so you want to count how many pieces of data that you combined. Okay, so for my example, these numbers are not real, they're pretend, but it's looking at somebody who's maybe getting this many hits for every baseball game they play in. So we're looking at a batter's outcome and how he did getting base hits throughout. This is going to end up being 10 different games. Okay, so I know that because there are 10 different numbers. So one thing that's always helpful when you're doing data analysis is to figure out how many numbers you have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First, I added up all the hits that this player was able to collect. So first game, he started off great, got 3 hits. That's super. That's good for baseball. Then he didn't get any. Pitchers figured out what he was doing. Then he got a hit. Then he got a hit. Then he didn't get any again. So you can see the first half here, he started off great, and then it kind of went downhill a little. After that, look at the second half of the season, better. He then got 2 hits, 1 hit, 3 hits, nice. 0 again, so bad game. And then 4 hits at the end, grand finale. He went ballistic. Okay, so I added them all up, got 15 total hits. You take all the hits, divide it by how many games that you just added up, and that would be 15 hits divided by 10 games. Hey, the average for this baseball player is he gets about 1.5 hits a game. So that's just what he averages. That's what the coach could expect when he inserts him in. Boy, you want to get really deep into this stuff is when you get into what's called lesson 2, when we get into mean absolute deviation. A little side note, you won't need this for the quiz, but you would see that this player had some really high good games and then some really low not good games. He was kind of all over the place. So his mean absolute deviation score would be a little higher than maybe other players who are more consistent, where they just usually get the same amount of hits each game. Okay. The things you may need to know for this is unit 7, I believe. It's definitely module 16, lesson 1, which is on both mean and median. So this is right here, this video is just on mean. Okay, mean is kind of mean because you got to do a lot of adding. When you do your work, you watch. If you make a mistake, almost always it's going to be in the adding. Seems simple, we're good at it, yet it's very easy to make mistakes. So check yourself when you're taking the quiz. Don't just add them up and go with that answer. Do it one more time a different way. Okay, you can see I'm kind of adding these 5, then these 5. Getting some subtotals is a safer way to sometimes do it instead of trying to keep track in your head all the way along. Now for these numbers, it wouldn't be as bad, but of course the numbers can get much bigger depending on what we're looking at. So be careful when you add. That's usually where the mistake lies, when somebody makes a mistake for mean or averaging. All right, quick jokes at the very end. All right, I once made a belt out of clocks. Ended up it was a waste of time. Waste of time. All right. How do cartoonists decide who's the best? Of course, they draw lots. Draw lots. Draw lots. Okay, I get it. Last weekend, I shot an elephant in my pajamas. How he got in my pajamas, I'll never know.